sketch the region and find the total area. So here we have that our region is just bounded by these curves. That's all we get. So we have three curves. We have the line, y is equal to 3 minus x. We have the x-axis, y is 0. And we have the parabola, y is equal to 9 minus x squared. So to help us with our sketch, let's actually begin by finding the bounds of this region. What are the bounding x values? So remember, to do that, we'll need to equate the curves and solve for x. So we've got a lot of curves here. I'm going to start with the most exciting ones. Let's take this line, y equals 3 minus x, and the parabola, y is equal to 9 minus x squared. And let's equate those. So since y equals y, we know that we could say 3 minus x is equal to 9 minus x squared. And we of course know that in order to solve for x, we've got to bring all of our terms to one side. So we can rewrite this as, we'll say, this will become x squared minus 9 plus 3 minus x is equal to 0. And we have two like terms that we can combine here. So this is x squared minus x minus 6. And we can factor this, so we can say that this is equal to x minus 3 multiplied by x plus 2 is equal to 0. And then applying that zero factor property, we have our two cases, x minus 3 equals 0 and x plus 2 is equal to 0. And so we can see our bounds on x. We have a bound at x is equal to 3, and we have a bound at x is equal to negative 2. So this will help us with sketching. So let's go ahead and let's think about what this sketch is going to leave us with. We should also actually make a note here before we do that. Shame on me. I totally left out the y-axis. So we can think about this as case 1. What about if we let, in case 2, what happens when we let y equals 0? What are those bounds going to be? So if we let y equal 0, then we're going to have 3 minus x is equal to 0. And so this shows us that x is 3. Hey, we already found that, so that's a good confirmation. And then we also need to think about the parabola. So we have 9 minus x squared is equal to 0, which tells us that x is going to be equal to plus or minus 3. So the negative 3 is new here, but keep in mind, I think that we already know that this must be bounded by where x is equal to negative 2. So while the parabola and the y-axis, or excuse me, the x-axis intersect at x equals negative 3, it won't necessarily be a bound, but we won't know for sure until we sketch the graph. So that being said, let's look at the graph now. So giving ourselves plenty of room, we want to sketch the region, which I'll call the region R and R2. Sketch this region bounded by our three curves. Again, we have y is equal to 3 minus x, y is equal to the x-axis, and y is equal to 9 minus x squared. So here we go. And so we have, let's see, our y-axis, and we have our x-axis, and we can move this down a little bit. So I'll do a 1-by-1 scale, and again, if you have graphing paper, I encourage you to use it for accuracy, but I'll say 1, 2, 3 on the x-axis, 1, 2, to minus 3 on the x-axis. We have that 1-by-1 scale, and then keeping our parabola in mind, we'll do a 2-by-2 scale on y. So we'll say 2, 4, 6, 8, 10. All right, so let's start by sketching the easy curves first. We know that this is bounded below by y equals 0. So here is the graph for y is equal to 0, the x-axis. We know that this region is bounded by the parabola that is reflected across the x-axis and shifted up 9 units. So here's that vertex at the ordered pair, 0, 9. And we know our parabola is going to intersect the x-axis at -3 and +3. So here is our parabolic region. So that's y is equal to 9 minus x squared. And now we also know that we have the line. So looking at our line here, we know that this line is going to have a y-intercept at 3, and it's going to have a x-intercept at +3 as well. Now we also know that this is going to intersect the parabola at 2. So we'll use these 3 points here to sketch our diagonal line. So there we go. So this green line is y is equal to 3 minus x. And we want to be careful here. We want the region that's bounded by the 3 of these. So we're talking about this region on the inside. So this half parabola shape is what we're talking about. Because we can see here is that point where it intersects the y-axis. Here is that point of intersection that we found. So we are looking for this area here. So again, when we think about this area, right, we see that if we think about, we'll say some arbitrary x value here, and if we draw a a vertical line anywhere on this sketch, we can see that the top curve is the parabola and that our bottom curve is the line. So we're going to again use that area formula that we just saw. So the area of this shaded region is going to be the definite integral from a to b of that top curve, which again is our parabola, minus that bottom curve, which is the diagonal line. And the bounds are from x is, that should be -2 to +3. So here we go, we can set this up. We have the area is going to be that definite integral from -2 to 3 of the top curve, which is the parabola, 9 minus x squared. And then we're subtracting the bottom curve, which is that diagonal line. So I have -3 minus x dx. And it is safe now to begin evaluating. Well, actually, we should distribute the negative first to make integration easier. So this leaves us with the definite integral from -2 to 3 of 9 minus x squared minus 3 plus x dx. And we can combine our two constant terms here. We have 9 minus 3, which leaves us with the definite integral from -2 to +3 of 6 minus x squared plus x dx. So here we go. We have integrating gives us 6x minus x cubed divided by 3 plus x squared divided by 2. And we can now evaluate from -2 to 3. So plugging in 3, we have 6 multiplied by 3 minus 3 cubed, so that's 27 all over 3, plus 3 squared gives us 9 divided by 2, minus, we have 6 multiplied by -2 minus -2 cubed will give us a -8 over 3, plus -2 squared leaves us with +4 over 2. And we can simplify. So let's see, we can rewrite this as 18 minus 9 plus 9 halves minus, so 6 times -2 leaves us with -12. We're then going to have plus 8/3 plus 2. And so before we distribute that negative, let's combine up our like terms here. So we have 18 minus 9 leaves us with 9 plus 9 halves. This will be minus negative 12 plus 2 is negative 10 plus 8 thirds. And now we'll take that negative and we'll distribute it through to both terms, which leaves us with 9 plus 9 halves plus 10 minus 8 thirds. And so 9 plus 10 gives us 19 plus 9 halves minus 8 thirds. And we're going to need a common denominator. So we'll think about 19 as being 19 by 1. And we want that common denominator. So we're going to multiply 19 over 1 by 6. We'll multiply 9 halves by 3. And we'll multiply 8 thirds by 2. So we have 19 times 6, which gives us 114, plus 9 times 3 is 27, minus 16, all over 6, which leaves us with the beautiful, so actually let's think, 114 plus 27 minus 16. So 27 minus 16 will give us 11. And now we have 114 plus 11, which leaves us with 125 sixths. So therefore, the area of the bounded region is equal to 120, oh, shame on me. It should be 125, all divided by 6 square units. And this is our beautiful final answer.